Today we're going to be using the properties of logs that we've learned previously, aka multiplication goes with addition, division goes with subtraction, the traveling exponent. Basically all those properties are going to be used now in order to solve these equations. Just as a quick review, let's take a look at just a regular solving one. So if I were to say the log base 2 of 1 minus 2x equals 3. Now notice here that's something they're going to help us out later. There's only one log term in here. Okay, later on we're only going to need one log term in order to solve these. Now I do need to solve for x. And remember, you can either go down and diagonal, or you could raise everything to that base power. But what I do to one side, I do to the other. So the log and the 2 exponent cancel, so we get 1 minus 2x. Now we have 2 to the third power, and remember 2 to the third power is an 8, and now this becomes an equation that's much more solvable. Subtract 1 over, okay, and then divided by negative 2, you get an answer of x equals negative 7 over 2 once you get x all by itself. Okay, but the key here is only one log term. Now, as we move on, there are some steps we want to look at for solving today's. So step number 1, condense the log. Write as one log term. Notice there, one log term. Change to exponential form like we did earlier, or you can use your down and diagonal. Check the solution with the domain. Log answers cannot be negative and they cannot be 0. So we're going to run into a couple cases like that. So let's take a look at our first example today. So we've got log base 6 5x plus log base 6 8 equals 3. Now there's going to be two types of problems. There's either going to be problems where all the logs are contained on one side of the equal sign, or there are going to be problems where there's logs on both sides. For here, these problems, or this problem right here, log on one side. Log on one side of the equal sign. Okay, so notice on this side there's just a 3 by itself. So step 1 is combine everything together until you get one log term, and specifically we're talking about the left hand side. So right now I've got 2 log terms, but they are connected using addition, and when we're condensing, addition becomes multiplication. We have no exponents that need to travel, so we're going to talk about these pieces here. Alright, so the addition is going to become multiplication. We're going to condense it down to one log term with the base of 6. So we have to deal with these. Addition becomes multiplication. So it's really going to be 5x times 8. And then on the other side is 3. And we can clean that up a little bit more. Log base 6, 5x times 8 just gives me a 40x equals 3. And now this should look like the example we did earlier. There's only one log term. We can either make it exponential form, or we could do down and diagonal, however you want to do it. I'll go down and diagonal this time. So the base comes down is a 6. The 3 comes over, becomes the exponent, equals the 40x goes to the other side. And now this is a solvable problem because log is gone. All right. 6 to the third power, if you hit that on your calculator, and let me see, 6 to the third power gets me 216 equals 40x. And then dividing both sides by 40 doesn't really come out nicely, so I'll write 216 over 40, but it does reduce to a 27 over 5. All right, now we don't really have to check this one because it's not a negative answer, it's not a 0, so that is a good answer for this one. All right, so we're solving for x. Let's take a look at another. All right, so we've got log base 3 x minus log base 3 x plus 5 equals 2. So again, we take a look at it. We've got the equal sign here. On this side, we've got logs. This side, no logs. So this is a problem where there's only one side of logs. Okay, and we'll see that on the third example, a different one. Now, I can't have multiple logs. Remember, step 1 is condense these down. and we look at how they're connected. This time they're connected by subtraction. And remember, subtraction turns into division based on our properties. And the things we're actually going to be dividing are the x and the x plus 5. This one has no exponents in the front, so we are ready to go. So we're combining into one log. Log base 3, subtraction is going to become division, and we work our way from left to right. X on top, x plus 5 on bottom. This thing's still set equal to 2. Again, you can make it exponential, you could go down in diagonal, take this base 3, raise everything to the 3 power, cancels that. So I've got x over x plus 5 equals 3 to the 2. Okay, so we keep solving here. I've got x over x plus 5 equals 3 squared is 9. And then, however you're ready to solve this, I've got multiple x terms over here. The way we get rid of the bottom is to multiply by that term, because remember, what's on top and what's on bottom will cancel. But what I do to one side, I do to the other. So I've got to multiply 9 out to both those terms. So I get a 9x plus, oops, oh, here I'm doing it wrong. Not just a 5, but a 9 times 5, which is a 45. I can combine some more x's together by subtracting 9x over. So negative 8x equals 45. All right, so divide both sides by negative 8. So in the end, x equals negative 45 over 8, because it doesn't simplify anymore. But, what type of answer did we get here? A negative. And can we have negative answers for logs? No, we cannot. So actually, not just crossing this out and not just saying it's 0, this is no solution. That's my actual answer here. There is no solution to this one. So we actually did all the work on there to get no solution as our answer. All right, one last example. Let's go ahead and solve log base 7 of 2 plus log base 7 of 2x equals log base 7, 66. So you notice what's different about this one? We've got the equal sign, we've got logs on the left and a log on the right. Logs on both sides. Okay, and we'll see what happens here. But just as before, we can't have multiple logs on one side, so let's condense this down. It's a an addition, which is going to become multiplication. So one log term, base 7, we're going to multiply the 2 and the 2x, and let's save some time, that's going to be a 4x equals log base 7, 66. Now the good thing about when there's logs on both sides, if the logs are both the same, you remember the property that we use here? Those logs just cancel each other out. So now we just got 4x equals 66. No exponential needed, no down and diagonal. Divide both sides by 4 is a 66 over 4. Or in the end, really just what is that, a 33 over 2? And there we go. And you know what? Just for fun, one more, because why not? Alright, so let's make this interesting. Let's say ln of x minus ln of x plus 2 equals 4. Now hopefully you remember ln is the natural log. Okay, it's actually French, logarithm naturel, or whatever you're supposed to say that in French. Okay, so just as before, you can kind of treat these ln's just like they were logs. Over here, there are 2 of them. We need to condense it down. Subtraction is going to become division. So we've got ln, x on top, x plus 2 on bottom equals 4. Okay. Now, if we don't see a base on this because we want to do our exponential stuff, on ln's the base is e. Okay? So in order to do this, we need to take this side to the e. Remember, the base is e. But what I do to one side, I do to the other. So e to the 4. These cancel. So we've got x over x plus 2 equals e to the 4th power. So let's go ahead and just leave that for right now. Now remember, e is on your calculator. Alright, so if I'm looking at my graphing calculator here, e is right above the ln button. Okay, you got a shift or second there, so you'd put e to the power of 4. And we're going to do that a little bit later. Alright, we do want to solve for x. And actually, we're going to keep e as e and just kind of leave it as a term. Just like as before, we need to multiply both sides by x plus 2. Cancel those. But what I do to one side, I do to the other, x plus 2. So x equals, alright, so we've got e to the 4 times x. Then we got to do it again, plus e to the 4 times this 2. Okay, so we're just kind of making a mess of things. Let's get our x terms both to the same side. So minus e to the 4x minus e to the 4x. Those cancel. So we've got x minus e to the 4x. Remember, e to the 4 is just a number. Just a number. Right now we're just seeing it as e to the 4 and we're not making a decimal of it just yet. Equals e to the 4. I'm going to throw the 2 in front because that's kind of bugging me. Now the reason we threw these to the same side is because we can factor out this x. So we got x, and what's left is 1 minus e to the 4 equals 2 e to the 4. And then getting x by itself, we would divide both sides by 1 minus e to the 4, this whole term here, because it cancels. And what I do to one side, I do to the other. Okay, so this is a nice advanced answer for us, or problem for us. So x equals 2 e to the 4 over 1 minus e to the 4. I mean, if you didn't like all that, you could have made e to the 4 as a decimal earlier. Because right now, if we look at this, it looks like an okay answer. And actually, hold on. Did I miss something? I mean, it looks okay right now. Okay. Now, one thing we do want to check. So I want to put this onto the calculator because something about this is probably going to bug me. Okay. So looking at this, this doesn't look too bad. But if I put this on the calculator, we do have to check for whether it's negative or 0 or something iffy about it. Because the problem is e is a number and we don't have it fully solved yet. So if I put this 2 times e to the 4th power on top, we get a 109.196. Okay, on bottom, 1 minus e to the 4 gives me a 54.598. And if we kind of look at this, on the bottom of this, 1 minus 54, that's going to come out to a negative 53-ish, right? And then that means the bottom is going to be negative. So if the top is positive and the bottom is going to be negative, this answer is going to come out to a negative number. Okay, so we couldn't have seen it from here, but this is a negative number. And can we have a negative number for an answer to a log? No, we cannot. So actually, we did all this work again to get what type of answer? No solution. All right, so the ln problem, a little bit more advanced because we're using that e symbol in there. We'll go through some more of those examples, but for right now, go ahead and take a look at these.